to use the Gauss law. I forgot to introduce one formula in Gauss law which is also important, and if needed I will just derive how it is formed. See, it's the Gauss law equal to Q by epsilon naught. Okay, you can just revise your notes. In meanwhile I'm just arranging the camera and just filling my markers in case of two. So in that there's a formula, E equal to delta S equal to Q by epsilon naught. This is a very important formula in Gauss's law, and it is derived through Coulomb's law, and all the derivations I will explain in another video in a detailed level. Okay, if I'm explaining this will make the concepts clear. This is a type of revision course, or if you don't know at all, you can just view also. If you want to know about capacitors, this is a nice video. Okay, so see now how nicely it's working. A equal to Q by epsilon naught, and I know Q equal to epsilon naught A into delta A. Okay, just cut it. So you got E equal to Q by epsilon naught A. This is a nice derivation. Now this is the field with area. Okay, now I'm going to explain field with our distance and both area. Okay, so another formula you have seen it. Okay, now I'm going to erase it. These derivations are very important and very useful, not only in this chapter, in whole electricity. Okay, yeah, so there's one formula in which delta V equal to integration of minus integration of E dr, dot product of dr. Okay, and V is electric potential. Okay, I forgot to tell you that force can be written as charge into electric field. Okay, and field is equal to force by charge. So the formula will be K Q by R square. Okay, and this minus sign is denoting the direction. Okay, now integration. If you, integration is simple. If you don't know, just I will make another video on integration and differentiation with highly conceptual part in it. I'll put highly conceptual part in it. Okay, so if the field is going, just say from A to B. Okay, I've assumed that the field is going from A to B. So B is the final, A is the initial position. Okay, so I'm assuming that A is the positive and B is the negative. So B minus. So I can say that voltage is equal to plus minus V of minus. Okay, this is the potential. It's not voltage, the potential of the positive direction minus the percentage of negative you have seen in the battery or capacitor. And this is big V, not small v. Small v is velocity, this is potential. And now I have given you the expression also what is potential and field. Okay, so I can write that V equal to integration of A B from dr. So there's another formula that V equals to ED, meaning potential, electric potential equal to electric field into displacement or distance displacement. Yeah, so now I will use that in my formula. So ED equal to, we got the E as, in the above form we got E as Q by epsilon naught A into D. Okay, now you may be saying this is dr and this is D. Okay, integration means adding of small parts and making it a full part. Okay, I'm adding small dr which makes D. Okay, so D. Okay, okay, just cancel out D. Okay, you will get that, and this is nothing but, and always you can see that V equal to Q D by epsilon naught A. Okay, just note it down, this is an important part. Okay, you guys can see, you will get just D. I will not just cancel it. So ED is nothing but V. I can write it QD epsilon naught by A. Great. Now if you have noted, now as we know that capacitance is Q by volts, potential. Okay, so C equal to Q divided by voltage, which is equal to Q epsilon naught A by QD. So C equal to epsilon naught A by D. So you can conclude one thing, that C is proportional to A and I'm sorry about this. C is proportional to A, directly proportional to A, and C is also inversely proportional to 1 by distance. This is epsilon naught is constant as I told, and which comes as 1 naught A by D. Very good. So if you have understood from this part, just like, and if you like this, share and subscribe. Yeah. Now enough for this, I think. Now if you understood the basics, you can go for the combinations of series and parallel. Okay, there is nothing to scared of. Okay, I'll just explain. This is a cell. Okay, I've kept two capacitors. Now many people have the misconception that series means if they are connected, just connected to each other, it is series. If they are not connected to each other, it's parallel. It's totally wrong. Okay, see, series is nothing but, okay, I've taken two capacitors, these, okay, this you can join. Okay, now if these two are in series, okay, how? Okay, there's one main important part in series. If two things are in series, there should be no junction in between. Okay, what is junction? Okay, if I take this part and connect with some another, this is not in series. Okay, there should be no junction in between them. Okay, now then only it's in series. And what is for parallel is these two are in parallel only if these two ends have two common ends. Okay, and they are in junction. Okay, they have a junction. Okay, they may not have a junction or have a junction, but for series, if they are in series, they should have junction. They shouldn't have junction. These 2 points are common for this, so these are in parallel. Okay, now what's the formula for if 2 are in series and 2 are in parallel? Sorry for the problem, due to the lockdown I'm not able to buy the important things for recording. Okay, so if 2 are in series, the equivalent resistance, capacitance is Q equivalent is equal to 1 by C1 plus 1 by C2. Okay, meaning 2 capacitors. This is C1, this is C2. Okay, so the equivalent is 1 by C1 plus 1 by C2. You want the derivation? I think it's not important now because we are running out of time. And if 2 are in parallel, you can directly add them. So C equivalent equal to C1 plus C2. Now I'm going to have an excellent problem. It's a very good problem. Till then you can just complete the notes. Okay, sorry for disturbance. We'll just go in a higher level question which is very good. Okay, I've written some nice questions which I thought I will solve. Yeah, I can solve with you. Yeah, okay. This is the question. See, you can see this is the question. Okay, I have to find the equivalent resistance across A and B. This is the capacitor. This is A. Okay, it's a capacitor. B. Okay, I will explain what is this. Only this part. This part is my question. Okay, this is a very important question. Please note it down. Just pause it because I am not able to hold it. Just pause and write down the question for it. Okay, now there is one important thing in this which you have to know. Okay, if this is B, yeah, if this is B, okay, if there is no resistor, capacitor or anything in between, you can just write this B here, continuing this till here. Okay, there's no capacitor in this line, no resistor, no battery, anything, there's nothing, bulb, even no bulb. So this B, I can shift it here and I can write as B dash. B dash is equal. Okay, this B dash I can write here because there is nothing here. Okay, now come to the A1. Okay, you may be thinking whatever I am telling is just rubbish, but it's not. Okay, now come to A. Can I write this A as A here? No, because there's a capacitor in between. Why I am telling, see, this is B, there's no capacitor, no resistor, so the voltage will be same or the current will be same at this part, this point also, because it's connecting bar. Okay, okay, how to solve this? First I'll write this as this. Okay, this is B dash, this is also B dash. Okay, and there is nothing here and here, this is also B dash, also B dash. Okay, now if I come this direction, this is the capacitor here, so I will denote this as C. Okay, and there's no capacitor in between, I will just denote this as C again. Okay, are these two in parallel? Just one thing, are these in parallel or series? Just think, these two, of course they are in parallel because there are two common points connecting them and there is also a common junction, so these both are in parallel. So as I told, for the parallel, I'll just parallel the equivalent resistance across CB is C1 plus C2, which is 12. So I can remove these two and just write 12 microfarads, because these two are in parallel. See, this comes with a highly practice. If you do high practice, you will easily do it. Now just see the upper part. Yeah, now I've removed the 12. See, I've denoted this point as D now. Okay, that is B only, so that is 12 and 6. Now tell me, is that 12 and 6 part above are in series or parallel? Just think. Okay, they are in series. Okay, how? See, these two are in a common wire and there is no junction in between them. See between them. Okay, these two are in series. These two are in series. There is no junction. If this is connected like this or somewhat, these two will not be in series. Okay, if I find the equivalent, is conductance between them, as I told that for series, you can see, yeah, I can just show you that for series, it's across B and D, it will be 1 by C equal to 1 by C1 plus 1 by C2. I can just write C equal to C1 C2 by C1 plus C2 by taking LCM. See, 6 into 12 by 6 plus 12, which came as 4 farads. Now you can just remove this and just write 4 microcoulombs. See, I'm taking the resultant or equivalent. Let's call it equivalent. Now just come down. This is nice question. Okay, now you can see that this is, as I told, this is D, B dash. Okay, this is 4 microcoulombs, this was 4, and this is 8. You can see. Now these two are in parallel. I think you got it, what is parallel and what is series now properly. See, now if these two are parallel, I can just remove this also across. Now I am going across D dash, D and B dash, which is 4 plus 8, 12 microcoulombs. Okay, now I came to just a simple figure out of this. Okay, I remove this 4 and 8 and just wrote 12. Okay, now across EB, not E, this is E, this is B. Okay, across E and B. Yeah, just tell me one thing, are these two in parallel? Just tell one thing, are these two in parallel? Sorry, I'm talking about these two. Sorry, I made a very big blunder. Okay, I'm talking about E and EB. Okay, E is this part and this. Okay, across this is the wire. Okay, so this, are these two in series or parallel? No, this one from E to B, not like this. Are these two in series or parallel? Of course in series, because there is no junction in between them. So across EB I got this as 4 microfarads. Now I can just write as that 4, just removing them. Okay, see, it's like this. Okay, I've removed 12 and 6 and wrote this. Okay, now easy, you can just write this 4. Now just tell me, is this 4 and 8 and series or parallel? No, they are in parallel. Okay, see, 2 common points, connecting them. Got it? I've just bended the wire, then nothing will happen. So I can just write as 12 and 6. Okay, as I know in parallel, okay, C1 plus C2 is equivalent. C1 plus C2, that is 12. And this is 12 and 6 as result. So these two are in series. There is no junction in between them. So as they are in series, so 1 by 12 plus 1 by 6 is equal to 1 by C, and 1 by 4 is 1 by C, then C is 4 microcoulomb. That's the resultant of A to B. Okay, you may be thinking it's very hard, but it's very easy. Now let's go to Wheatstone bridge, the main topic. Now whatever I told was just the introduction and basics. Now, okay. Wheatstone bridge. See, consider this circuit. Don't worry, I've just gone to a very higher level question after teaching you series and parallel. If you understood that, you have done a very great job. Means you have understood the basic problem easily. That's very almost a tough problem, not very tough. It's medium type. If you solve that and understood, it's very easy. Okay. Now Wheatstone bridge. This is a very important tool used in the resistors, capacitance and current electricity. Okay. See. Now I have a circuit like this, you can see. Okay, this is A, B, this is C1, C2, C3, C4, C5 in between. See, if this comes something like this, okay, can you say C1 and C3 are in series? Just think, ये दोनों are these two in series? No, because there's a junction in between. Are these two parallel? No, because there is another in this. These two are also not in parallel. These two are also not series. If something comes like this, then if there is two cases in this, if C1 by C, C1 by C1 by C2, if C1 by C2 is C3 by C4, if this is case number 1, if this comes, then there will be no current passing through C5, only this area, this area, only this. So see, this is the formula for it. See, this is the battery which I have connected. Okay, this is C1, C4, C3 and C5. Okay, if C1 by C4 is equal to C2 by C3, it's the ratio is equal, then there will be no current pass through C5. This is very important. Wheatstone bridge. So, and this is also used in parts like there's in this capacitor is not series nor in parallel. These both are not. See, I'm going to explain one thing. See, this is very important. See, come. Easy manner. I will explain in an easy manner. See, so see, these are two resistors, sorry, capacitors. Okay, sorry, I'm not able to draw properly. Just please adjust. After lockdown, I will just bring the equipments and do it. See, now this is very important. Just don't have any distractions, no games, nothing. Just concentrate. This is positive, this is negative. Okay, so this is plus q. The plus q charge will flow from this direction, and the minus q charge will flow this direction. Okay, now these two, if comes here this point, okay, plus q minus q. This is very important. Now here I will just assume as q3 minus will go this, and q4 minus will go this way to this capacitor. Okay, and sorry, I forgot one thing. There is a junction between these two. Okay, and similarly q1 will go here, q2 will go here, positive. Okay, so minus q1 charge will develop here, my plus q charge will develop here on this plate. Here minus q3 plus q3, here plus q2 minus q2. Yeah, this is just rubbish. I will just very bad. I will just explain and draw it freshly. Okay, and this is minus 4 and this is plus 4. Sorry, I'll just now just draw the capacitors. Only the capacitor part. Here in this minus q3, this side minus q4, this side plus q1, this side plus q2. Now it will be clear. It's not so bad, I think. Okay, if you are not able to see, now here plus q2 charge will form, and here minus q2 charge will form. Here minus q4 and here plus q4 in this plate. This side, okay. This side plus q1, this minus q1. this will be minus q3, this will be plus q3. Okay, this will be the circuit. If in this I have assumed that equal current will flow in the both directions, and I also told that in this is C2, this is C1, this is C4, sorry, C3, this is C4, this is C5. Okay, and I also told that C1 by C2 is equal to C3 by C4. It does not happen. This is case number 1. I will in next video I will explain case 2. If this happens, okay, then, and also if I told that Q1 plus Q2 equal to Q3 plus Q4. I haven't even told this. Okay, so just I've just told this also. Okay, you have noted down. Okay, and there is something called as potential difference. Potential difference.